All right, so today we're going to be talking about lesson 5. This is called negative exponents and zero exponents. So if you recall from lesson 2, as I increase the exponent, it adds one more base that we're multiplying together. So 3 to the first is 1 3. 3 to the second is 2 3's multiplied together. As we increase the exponent by 1, we multiplied by one more base. Same thing here, as I increase from 2 to 3, I multiply by one more base. Same thing from 3 to 4, multiply by one more base. As we went in the opposite direction, as I decreased my exponent from 4 to 3, I divided by a base. Same thing from 3 to 2, I divided by the same base. From 2 to 1, divided by one more base. What about if I continue to do that? So, 3 to the first is 3. As I decrease the exponent, I divide by a base. So 3 to the 0 would be 3 divided by 3, which is 1. As I decrease the exponent again, it's 1, which is the previous number, divided by 3, which is 1/3. As I move again, I divide by 3, so this is 1/9. I'm wondering if you notice too, this is the same as 1/3 to the first. 9 is 3 squared, so 3 to the negative second power would be 1/3 to the second power. That is true all the time. So if I have 6 to the negative third power, it would be the same as 1/6 to the third power. And that's how negative exponents work. The negative part of the exponent flips the term from where it is to the opposite part of a fraction. So for example, 3 squared, this is really in the numerator of a fraction because I can put it over 1. If I have 3 to the negative second power, this is still in the numerator. But the negative sign means that it turns into its reciprocal, the opposite part of the fraction. So now I have 1/3 squared. So let's utilize that information to help us with some of these examples. Example 1. Rewrite this with a positive exponent. So 4 to the negative fourth really means that this is in the numerator. The negative sign means I flip it to the denominator and get rid of the negative sign. So now this is 1/4 to the fourth. Example 2. Same thing. I have c to the negative seventh. This is in the numerator. So in order to get a positive exponent, I have to flip it to the other part. So c to the negative seventh in the numerator becomes c to the positive seventh in the denominator. Now, what happens if I have a positive exponent already? So I have f to the fifth in the denominator. If I wanted to rewrite this with negative exponents, I have to work backwards. So again, these two flip positions. So now I have f to the fifth in the numerator. But because I flipped it from the denominator to the numerator, my exponent now becomes negative. And same thing with example 4. We've done this one already. But if I want this to be a negative exponent, I have to flip the position of the 3 squared. So now it becomes 3 to the second power in the numerator. I flipped the position from denominator to numerator, so now it becomes a negative exponent. Last couple questions. These are going to be taken into account. This is our product of a power rule. From lesson 3. And this is our quotient of a power rule. So in example 5, product of a power rule says if I have the same base multiplied together, I add the exponents. So this becomes 4 to the negative 5th plus negative 3. Negative 5 plus negative 3 is negative 8. Now, if I wanted to rewrite this as a positive exponent, again, this is as if it's in the numerator, so I need to flip it to the denominator. So I have 1 over 4 to the 8th. The exponent is now positive because I flipped from the numerator to the opposite part, the denominator. Example 6 now. Quotient of a power rule states if I'm dividing two like bases, I keep the base and I subtract the exponents. Negative 5 minus a negative 7 is the same as negative 5 plus 7, which means this is c to the second. All right, that's the end of lesson 5. If you have any questions, please let me know.